why do we need to talk about normal gait? As physical therapists, gait, or the assessment of gait and walking, is one of the prime functions, one of our major roles. We are the experts in gait and evaluating gait. And it is one of the primary goals that many of our patients have to walk and to improve their walking. So it's very important that we all be familiar with gait and we know the terms and we have a good, thorough understanding of gait. In order for our patients, what we want to do is to look at patients who have problems, what we call pathological gait. But before we can do that, we have to understand normal gait. So normal gait is the key to understanding pathological gait. It's not until we understand what normally should happen during walking, what muscles are active, what the motions are, what gait looks like, can we make a determination if our patient is walking abnormally. So it's very important that we understand thoroughly normal gait, and that's why we're going to be spending so much time on normal gait. Many of you have learned different ways of studying gait. This is what we're going to present is a systematic way to not only understand normal gait, but use that same system in assessing pathological gait. And this system is devised so that we can identify the problems that our patients have, and then use those problems and that method to then design treatment. This system also has a clear language where we can communicate, and if we identify or describe what's happening to our patient, that we are all using the same terminology and we'll all understand what we're talking about. So again, gait is very important in terms of evaluating and treatment, and this system will give you those tools to start that process. There are some resources that we'll be discussing. The primary one is Observational Gait Analysis, a book written by a rehabilitation facility in Los Angeles, California, called Rancho Los Amigos Medical Center. If you haven't heard about this before, Rancho Los Amigos is a rehabilitation hospital in Los Angeles that's been in existence for over 100 years. And in the 1960s, a physician named Dr. Jacqueline Perry, who was an orthopedic surgeon who started out as a physical therapist, went back to medical school to become an orthopedic surgeon, and she started one of the first gait analysis laboratories in the world. It was through her support and training and mentorship that the physical therapists in that facility developed this observational gait analysis system. In addition, some of the information and data will come from the Center for Cerebral Palsy at UCLA's Cameron Gait and Motion Analysis Laboratory, as well as sources from the literature. Okay, so what is normal gait? So again, before we learn about pathological, we have to have a thorough understanding of normal gait. What is normal gait? First of all, normal walking is efficient. And it's efficient for our musculoskeletal system and our cardiorespiratory system. What do we mean by that? That normal individuals use only approximately 30% of their muscular activity or muscle force when walking. Additionally, we use approximately 30% of our cardiorespiratory reserve when walking. What that means is that normal, typical, healthy individuals can essentially walk all day. We have a huge reserve with which to draw upon if we need to. Walking is not a taxing activity. It does not tax our cardiorespiratory or musculoskeletal system. Normal walking doesn't cause pain, and it doesn't cause joint deformity. It doesn't cause any damage to our bones, muscles, or joints. Now, many of you may have learned a description of gait in the very basic form, which is correct, which is divided into two phases: stance, which is when the foot is on the ground, and that's approximately 62% of the gait cycle, and we'll talk about that. And swing, which is when the foot is off the ground, which is approximately 38% of the gait cycle. So let's first talk about what do we mean by a gait cycle. When we talk about gait or walking, we look at one leg at a time. A gait cycle is from the moment one leg, in this case my right leg, when this one leg hits the ground until just before that leg hits the ground again. That is one gait cycle. And that gait cycle includes what's happening on the other leg. So it's just offset, okay? So one gait cycle, again, includes both stance and swing from the moment the foot hits the ground until the same leg hits the ground again. The system that I'm going to teach you divides this gait cycle up into 8 different phases, 8 different periods, and different things are occurring, different motions are occurring throughout those periods. We are going to talk about different components of those phases. The first of which is what we call, from biomechanics or from a laboratory, we call kinematics. Kinematics is the range of motion or the movement that occurs during the gait cycle. Now what we have up here is a picture of our laboratory and how those kinematics are achieved. So those kinematics, we are explaining, what we're going to talk about is observational gait, what we can see. But the data that we're going to be describing is actually obtained from a laboratory, what computer-aided motion analysis, the same technology that is used to generate video games and all the computer, CGI computer-generated special effects in movies, actually took their technology from gait analysis laboratories. So the kinematics is obtained, and you'll have a picture up here of somebody with the markers, in a laboratory where photoreflective markers are placed at specific points along a person's joints. And then cameras around the room observe or track the motion of those markers and generate the motion. So this is important because at some points we'll talk about some motion that the computer or the laboratory tells us that a joint is moving, but our eyes don't necessarily always see that exact motion. And we'll discuss the differences between what the computer tells us is happening and what our eyes can see. But that's kinematics, motion. We're going to be describing what happens at the different joints of the lower extremity throughout the gait cycle. The next is kinetics. Kinetics is the ground reaction force, and we're going to talk more about that. But basically, we know from Newton's law that for every action, there's an equal and opposite reaction. When we touch the floor actually pushes back on us. We don't feel it, we don't see it, but the floor pushes back on us. Our pushing down on the floor and the floor pushing back on us is in part a result, or can be best described as gravity. Now we can't see it, but the gait laboratories can actually capture that force. And we'll have a picture of the force plate. And when a person walks over this force plate, we can actually project that force, and we'll talk more about that. And we describe that when we're talking about gait as joint moments. Essentially moments used in the physics term of a force acting on a part. The last thing we're going to talk about is electromyography. And electromyography is when electrodes or sensors are placed on muscles, and we tell and this tells us when the muscle is on or off. And we can show a picture of the electrodes if you want. Electromyography is obtained through various types of sensors, but essentially we're just putting sensors on, and for the most part we're just talking about whether the muscle is on or off, and when it comes on and when it comes off. Now this is important. It's important to understand when a muscle comes on and when a muscle comes off, and it's important to understand that for normal, because when we start looking at a patient, if we're looking at the cause of what the problem is for a patient, we have to understand that if we think that a muscle is weak and that that's causing a particular problem with the patient, if that muscle isn't normally active during that phase, then weakness of that muscle cannot be a problem. So again, using our knowledge of normal helps us understand what we look at in pathological. Okay, so what we're going to do now is start talking about the phases of gait. Okay, so the first phase, and what we're going to do is we have these in English and in Ukrainian. Okay, all right. The first phase of gait is initial contact. Initial contact is just a moment in time. So even though we call it a phase, it really is just how the foot contacts the ground. It is really a connection point between the previous phase, which is terminal swing just before the foot hits the ground, and the next phase, which is loading response when the weight is loaded. The important thing at initial contact is that we land with the heel first, or heel contact. Now some of you might have heard of the term heel strike. How many of you have learned that term heel strike in learning about gait? Okay, a few of you. Heel strike, this is the moment that you're talking about. Heel strike is not an incorrect term. But remember we said that this method, that what we're going to talk about, is a systematic way to not only understand normal gait, but pathological gait. And when we talk about heel strike, it's adequate and it's appropriate and to use when we're talking about normal gait, when we strike the ground with the heel first. But we know that many of our patients do not have contact with the heel first. Then using the term heel strike becomes more cumbersome, because you have to say they didn't have a heel strike, and then you have to say how they did contact the floor. So instead the term initial contact was developed, and now we talk about how they contact the floor, either with the heel or typically the forefoot or foot flat. But that's what you learned about when you learned about heel strike. Okay. So, so just a little bit of orientation here. You're going to look at all of these videos, all of these slides. Now in your books, you don't have these slides. They don't copy well. They don't copy well in the material. So instead you have drawings that are from the Rancho Los Amigos book. The drawings that you have, can we pause that for a second? No, pause the